The idea of traveling through time has fascinated humanity for more than a century. Traveling through space and time at a whim does sound like a scientific fantasy. With modern travel's physical constraints, however, new research suggests that traveling through time may be achievable, but it may be rather risky. Keep watching till the end of this video as scientists reveal how time travel is possible. These theories are mind-blowing. Welcome to Space Infinity, Time Travel. Among the many ideas of the known and unknown universe that humankind has always found intriguing is the concept of time travel. Nowadays, traveling through time may seem quite prominent in pop culture, with plenty of time travel stories referenced in movies, TV, and throughout literature. From one of the earliest time travel stories in the Greek tragedy Oedipus Rex, written by Sophocles over 2,500 years ago, to the world's mightiest heroes, the Avengers, using time travel to beat Thanos and fix reality. Traveling through time is a tool and a concept that has prevailed through time. Who in fact wouldn't want to have the ability to travel forwards or backwards in time? Not only to witness historic spectacles in time, such as the early beginnings of the universe, but also to change realities as we know it. But is time travel in fact possible? This legitimate question has been a subject of research and theories, with scientists keen at finding the answers to universal theory. Currently, the simple answer to this question is that time travel cannot be possible. Otherwise, human civilization would have knowledge on how to do it or would already be doing it. The ability of traveling through space-time is argued to be forbidden by the laws of physics, such as the second law of thermodynamics or relativity. The concept, which has long been embraced by science fiction, finds itself as a topic of constant debate by theoretical physicists. Many of these scientists find some common ground, such as the possibility of time travel, but with the involved vast amounts of energy, or that traveling to the future may be doable, albeit a bit of a one-way ticket. To understand this further, we need to understand what time is, and just how we travel through it. The concept of space-time. Time is familiar to everyone, yet it's hard to define and understand. It's more than the hands on a clock that tells us what the time is, with science, philosophy, religion, and the arts having different definitions of it. However, as a system of measurement, it is relatively consistent. Classical mechanics state that time is the same everywhere. We all understand that while you may stand still at a given space, time will move forward around you and within you, and there's nothing you can do to stop it. Physics defines time as the progression of events from the past to the present and into the future. It is considered the fourth dimension of reality, and is used to describe events in three-dimensional space. Time is something we cannot see, touch, or taste, but can still measure its passage. Despite time not having matter, it matters so much. Well enough, in fact, that we try to decipher the ways we travel through it. In fact, we are all doing it right now, traveling into the future at the rate of 1 second per second. Whether you're witnessing something slow or fast, all of us that exist in reality move through time at the same speed. Not anyone has the ability of easily moving through time, changing the past, or seeing the future before it happens, as no one has ever demonstrated the kind of back-and-forth traveling in time as seen in most science fiction. As famous physicist Stephen Hawking pointed out in his book Black Holes and Baby Universes, the best evidence that we have that time travel is not possible and never will be is that we have not been invaded by hordes of tourists from the future. Time naturally moves forward, which is why traveling through it as easily as energizing a plutonium-powered DeLorean isn't as easy as it's thought out to be. Science states that time travel violates the second law of thermodynamics, which states that entropy or randomness must always increase. Time can only move in one direction, and as such, you cannot unscramble an egg you've placed in a pan. Traveling into the past from a present or now that has a high entropy state into a past that leads to a totally new present and future which has a lower entropy is a violation of the second law of thermodynamics. Science does, however, support some amount of time bending. In fact, another famous physicist, Albert Einstein's theory of special relativity, does propose that time is an illusion, moving relative to an observer, and when that observer is traveling near the speed of light, he or she can experience time much more slowly than an observer at rest. This includes time's after effects, such as the passage of time or boredom, and physical aging, among others. This theory is demonstrated when astronaut Scott Kelly aged ever so slightly less over the course of a year in orbit around Earth, compared to his twin brother who stayed on the planet's surface. Einstein's theory of special relativity is the basis for real-world concepts and research on the possibility of time travel. To understand this concept better, Einstein re-envisioned space itself by coining the phrase space-time. The fabric of space-time is a conceptual module that fuses the three dimensions of space with the fourth dimension of time as a single concept. Space-time is simply the physical universe inside which we and everything else exists. With this model, Einstein highlights his theory of special relativity by focusing on time being relative depending on how fast you are moving within space-time. This is how we can better understand and acknowledge that time travel is indeed possible through these time dilations. The faster you move through space, the slower you move through time. The tenets of Einstein's theory of special relativity, as well as his later expansion, the theory of general relativity, has since become the foundation of modern physics and has three pillars. First is that all things are measured in relation to something else. That is to say, there is no absolute frame of reference in the universe. Second is that the speed of light is constant, no matter where it's measured from. Third and last is that nothing can go faster than the speed of light. And while we may not be accelerating anyone to near light speed as of late, we do witness the effects of Einstein's theories from the astronauts we send out into space. Astronauts who log in numerous days in space experience time differently due to the difference in speed they're traveling while in orbit. According to special relativity, the faster an object moves relative to another object, the slower the first object experiences time. This also applies for GPS satellites that operate with atomic clocks, which result in each satellite cutting 7 microseconds, or 7 millionths of a second each day as it orbits around the planet. Meanwhile, general relativity also theorizes that clocks closer to the center of a large gravitational mass like the Earth may tick more slowly than those farther away. This adds another 45 microseconds onto those GPS satellites, which are much further from the center of the Earth, compared to the clocks that are on the planet's surface. In order to maintain the accuracy of our atomic clocks, engineers account for these lost microseconds, 38 microseconds in fact. This type of time travel may seem negligible, but it is indeed the clearest description of time dilation, and in essence of time travel itself in effect today. There are, however, more radical theories that open the possibility of traveling through time with the use of advanced technology. General relativity provides scenarios that could allow travelers to go back in time using wormholes, or theoretical tunnels through space-time that could connect different moments or locations of reality to others. These wormholes are also called Einstein-Rosen bridges. Other researchers have also proposed numerous solutions that could allow jumps back and forth in time, with these alternative theories having quite a major flaw: finding a way back. Astronomer Frank Tipler proposed a mechanism that rolls matter 10 times the sun's mass into a long, dense cylinder to create a black hole. Another theoretical physicist from the Technion Israel Institute of Technology, Amos Orai, also suggests a time machine made out of curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. This time donut spacecraft has the ability to manipulate gravitational fields at will to create an area with a warp where timelines close on themselves. However, these concepts, of course, are all theoretical, and as far as science can tell, there's no way a person could survive the kind of gravitational pulling and pushing that these solutions require. These concepts are also currently beyond our immediate technological reach, so whether we can witness humanity having the capability of these incredible feats, only time will tell. So, what are your thoughts on the possibility of time travel? Let us know in the comments below. Space Infinity will continue to deliver the latest news on the vast oceans of space and all its new discoveries. So tap that like button and subscribe. We'll see you in the next one.